Okay, Alec Kovaleski, your instructor for Irrigation and Drainage Hort 360 here, and this is our last lecture for the term. We're going to talk about surface drainage systems now. Okay, so in our lecture related to surface drainage systems, we're going to talk about intercept drains, catch basins, and dry wells. So this is, again, our surface drainage system lecture here. So in our previous lecture, we talked about subsoil drainage systems. And remember, in our subsoil drainage systems, we're putting drain tiles down in the subsoil to control the water table. So if we put drain tiles down in the subsoil, we have these drain tiles move water to low-lying areas. We can then decrease down the water table and stop the soil from saturating up from the bottom here. Okay. However, when it rains, we will still get more water on the top of the soil. And if we have a loam soil, the fastest we will have water draining through that will be 0.4 inches per hour. So we still could have a circumstance when water could pool on the surface when we have a loam soil because it just can't drain through the surface fast enough. Okay, so let's talk now about surface drainage rather than subsoil drainage. So in terms of surface drainage, we're often talking about intercept drain tiles or French drains. Okay, so an intercept drain tile system is going to have drain tiles that move water off the surface, but they have a very coarse material like a sand, a fine sand, or a coarse gravel or medium gravel put here over top of the drain tile, going all the way up to the surface. Okay, so remember here, this native soil is going to drain very slow. If it's a loam soil, the fastest it can drain is like 0.4 inches per hour. But if we have a fine gravel here over this drain tile, it could be draining as fast as 19 inches per hour. So when the rain falls, it'll get the soil wet. Any water that doesn't drain into the soil will start to roll off the surface here and collect. And as the water rolls off the surface, as long as there's an adequate slope to direct water off the surface, it can then be caught by an intercept drain. If that intercept drain has coarse sand or gravel in it, it can drain very quickly down to the drain tile and then move off of the surface with that drain tile. Okay, so this is the difference between an intercept drain and a subsoil drainage system. And remember, the subsoil drainage system controls the water table, while an intercept drain tile system is moving water off the surface. Okay, so I'm going to break this down here in a couple slides. On the right over here, you have a square which represents a loam soil. And remember, this loam soil can only drain as fast as 0.4 inches per hour. So we're going to take this loam soil, we're going to see that water pool on top of it can only drain 0.4 inches per hour. Okay. If we then cut a drain tile down into this soil, so we trench a line in here into this soil, the loam soil. We then put a drain tile in the bottom of it, and we backfill this area with like a fine gravel or a sand material. Let's say we use a sand material with an infiltration rate of 1.5 inches per hour. So that's going to be substantially greater than the loam soil, which is 0.4 inches per hour. And then as long as we've got a surface slope that can direct the water across the top of the loam soil and into the sand, it can then find its way into the drain tile and drain off the surface here. The primary component here, though, is two things: to have a surface slope that moves water that's not infiltrating down into the coarser native soil, and having a very coarse textured material like sand or fine gravel over top of the drain tiles to provide rapid drainage down into the drain tile. And that material has to go all the way up to the soil surface. If we get any native soil over top of this, again, the fastest it can drain is 0.4 inches per hour if it's a loam soil. So we want to try to keep any native material off the top of this intercept drain or French drain system. Okay, here you see example with fine gravel over top of that, which would then drain at 19 inches per hour. So very fast drainage if you had fine gravel instead of sand over top of that drain tile. Okay, and here's a drawing of a typical intercept drain tile system. So this would be for like an athletic field. So most athletic fields are built with a crown, native soil athletic fields that is. So there's a crown on the soil surface, and ideally water will come down here and hit the soil. It'll start to drain down through the native soil, but that'll be very slow. So anything that's not draining down will now start to roll off the surface. Once it finds its way to this intercept line that's filled with sand or fine gravel to the soil surface, it now can infiltrate down quickly into the drain line, which has the drain tile that moves the water off the soil surface. So that's a drawing how a slope and intercept drain tile system would work together. Okay, and you would ideally have some kind of lateral drain and main drain, so your laterals would connect to your mains, which would then move the water off to a catch basin or a dry well somewhere on the corner of these fields or landscapes where you want to drain the water off. Okay, so here's an example of an intercept drain tile system we're installing on campus. I believe this is behind Weatherford Hall with some of the grounds crew at OSU. So here we have installed we cut a trench first. We dug out a trench with the trencher here on the right. We then line the trench with this fabric material, put a drain tile down in the bottom of it, so we have a perforated drain tile, and then we're putting fine gravel over top of that perforated drain tile. Okay, so you've got the drain tile with fine gravel over it. You've got the geotextile fabric in there to stop the native soil from getting into the fine gravel in the drain tile. Okay, and then in the next picture here you see we're putting sand over top of the fine gravel or stone here to provide a media that can hold just a little bit of water to grow some plants, some grass, but still have very rapid drainage. So now we have reduced down the ability of water to drain through this system to about 1.5 inches per hour with the sand, because we put sand over top of the gravel. Okay, and that's an example of an intercept drain tile system. And you see here, the idea is water will move across the native soil to the drain tile here, or across this sidewalk to the drain tile, where it can then move more rapidly through the drain tile here, which is then going to be tied into this catch basin over here where water can collect. Okay, there's a final picture on the left over here of our intercept drain. You can see we trenched it in relatively shallow. We put fine gravel over top of it. We're going to then put a layer of sand over top of that to finish up the drain tile system and hopefully provide something that can allow for relatively rapid drainage of water that rolls across the driveway or the sidewalk here, or across the native soil here to the drain line. All right, here we see another example of an intercept drain tile system. So this is a project out at Lewis Brown Farm where we were renovating one of our research turfgrass areas. So here you have the native soil, and then you've got a series of lateral drains and then a main drain here where water can move through this part rapidly, and we're putting gravel over top of the drain lines there. So you've got the drain lines filled with gravel over top of the drain tile. And then here's another picture of that. You see the drain tiles with the fine gravel going over top of it and around it. And then we're going to put a blanket of sand over top of that fine gravel. So This is kind of how it would ultimately look. We have the drain tiles down in the bottom, fine gravel filled up in the trench, and then a couple inches of sand over top of that entire system there to provide a nice intercept drain tile system. And again, the key component here is not having native soil, which has a slow drainage rate up here, impeding the flow of water to the drain tile. Okay. Here's a example of a French drain, and usually the difference with a French drain here is you have fine or coarse gravel going all the way up to the soil surface. You don't have any sand on top of it here to provide some media for plant material to grow in. If it's just gravel all the way up to the top, we typically call it a French drain rather than an intercept drain. Okay. All right, so we talked about intercept drains and French drains. Now let's talk about catch basins and dry wells. So a catch basin is a place for water to drain across the surface and then go down into a hole, which is often then connected to a series of drain pipes. So here's a drawing of what this often looks like. So you got some kind of open pit here that can collect water that runs across the surface, goes into this catch basin, and then that catch basin ties into a drain tile system, which can then lead the water away very rapidly. Okay. So here we have a quick review of the intercept drain tile system. So remember here, in this example, we have the loam soil here, we have a drain tile here, and we've got fine gravel over top of that. And water is going to run across the surface because it's falling faster than it can infiltrate through the loam soil. It's going to find its way to the fine gravel if there's an adequate slope, and then it's going to move down through the fine gravel at 19 inches per hour into the drain tile. So with the catch basin system now, what we're doing is instead of having the fine gravel over top of the drain tile, we just have this grate system, which the water comes across the surface, it finds this grate, and it falls through the openings of the grate into the catch basin, and then the catch basin is tied to a drain tile, which allows for very rapid surface drainage once it makes it to this catch basin here. So I got a couple examples of catch basins around OSU campus. Here's a picture from outside of Dixon Recreation Center, and there's a catch basin here. I believe this is on the northwest side of the building here. You got the bike racks and a sidewalk, and everything is sloping down to this catch basin here. Okay, so I've drawn the arrows of the surface slope to the catch basin. We're going to then zoom into the catch basin here, which looks like this. I had to peel back some of the grass for the picture here, but now you've got this grate system here, this kind of like a manhole type thing with these big open holes where water can flow very quickly into this catch basin system. That's then tied into a series of underground drain tiles, which moves water off the surface very quickly. Then I'm moving a little further down along Dixon Recreation Center. We're now towards the southwest corner of the building, and again there's a catch basin here underneath the trees, and the surface moves from the sidewalk down to here and from the building down to here where the catch basin is installed here in the grass. And then this is our close-up picture of that catch basin. Again, you can see these big grates in the opening, which allows for water to flow off the surface through this, and then it then ties into underground drain tiles that move the water off the surface there. Okay, here's another catch basin system. So this is over at the Into building. This is down at the very south end of campus. So OSU campus, the slope goes from north to south. So water has a tendency to drain across campus. So usually when you go to the more southern end of campus, you'll find wetter and wetter soil conditions. And here you have this surface that slopes down towards this sidewalk. And in the sidewalk, they have this catch basin installed here. So water will actually run across the surface, over into the sidewalk, or across the sidewalk here to the catch basin. And the catch basin collects it as it runs across the surface. It's then here tied into a drain tile system, which moves the water underground off the surface. Okay, there's more collective pictures of all the different catch basin samples I have collected across campus here. Okay. All right, our final picture here shows a catch basin being tied into an intercept drain tile system. So here you have the intercept drain tile, the drain tile here with the fine gravel around it and then sand on top of it so water can flow over the sidewalk or across the grass to the drain tile here. It is then going to be tied into this catch basin here, which collects water that runs across the surface here of the grass. That catch basin is then tied into underground drains that move the water off of campus to low-lying areas on the outskirts of campus. Okay. All right, so we've talked about intercept drains, catch basins. Now let's wrap things up with a quick discussion on dry well. All right, so in the picture here on the left, I have a drawing of a dry well. So here is a catch basin tied to a drain tile, and on the right is an intercept drain tile, perforated drain tile, or a drain tile that's installed for managing your water table. But ultimately, these catch basins, and I've also got a drawing of a manhole cover here on the top of it. What the difference here is with your dry well is the intention is to move water to this well and then incorporate water back down into the ground. So ideally your water table is down here underneath the dry well, and the dry well does not have water in it during the dry parts of the year. And when it rains, water flows through your drainage system or over the soil surface to the perforated top of the dry well, and it moves down through the dry well and is incorporated back into the soil above the water table. So this is different than a wet well or an artesian well, which we see on the right. So the intention of a artesian well now is to draw water up out of the ground and use it for irrigation or drinking. Okay, so this type of well is sunk down into the water table, so when you look down into it, you see water in the bottom of it. And the idea here is to use it as a way to draw water up out of the soil, while a dry well is a system to incorporate water back into the ground. Okay, so again, a dry well is for moving water into the ground, where a wet well or artesian well is for pulling water up out of the ground to use for irrigation or drinking. All right, here's some pictures of dry wells that we put in. Again, this is a drainage project we installed at the Lewis Brown farm. You have a series of drain tiles here and stone that's going over top of them. We'll eventually put some sand over this as well. And these tie into this dry well here, which also is going to have a perforated cover over the top of it, which allows for more surface water to infiltrate down into it. And ultimately what this does is it provides a way for water to go back down into the subsoil here. So this drain tile system will connect into this dry well, and then it then incorporates water into the ground. Okay, so that's example. Here's another picture of a dry well. You would see something like this in a basement. So here you have bricks lining the edge of the dry well. You've got bare soil at the bottom here, and then a drain in the basement bringing water to the dry well, where it will then be incorporated back down into the ground. So this serves as a holding pin for water when it's draining quickly, and then it slowly can integrate back down into the ground through the dry well. Okay, so that concludes our lecture on intercept drains, catch basins, and dry wells, which are all part of the surface drainage system. Okay, our intercept drains and our catch basins will often tie into a dry well, which is how we incorporate water back into the ground after it's been drained off the surface. All right, it's been a great term, everybody. I hope you enjoyed this course, Irrigation and Drainage. It's been a lot of fun, and I will talk to you later. Have a good time, and see you around.